Hello. Today I continue with the demonstration of how to create a simple USB MIDI converter based on the STM32 microcontroller. In the last video I talked a little about development boards on the basis of which you can build your projects. I also created a basic project using CubeMX to implement my firmware. As you can see, I have already connected the necessary things to the development board. On the one side, we have a USB adapter connected, and on the other side, a board with LEDs is connected to the corresponding outputs. I mounted on a test board 4 LEDs with 4 current limiting resistors. The color of LEDs is red, orange, green, and blue. I will show you a diagram of all connections on the screen, so you can see this. On the right side we have a little USB adapter PCB with mounted configurable resistors. On the left side we have LEDs connected to our nuclear board. And as for nuclear board pinout, you can find a nuclear board pinout somewhere in the internet. I found some of detailed view of nuclear board pinout at this website. I only connected my wires to the necessary pins that I already configured with CubeMX. At first, I will connect my nuclear board to PC. Then I will try to flash my basic firmware. At first, I will press the build button. We can see 0 errors, 0 warnings, and after that I press the debug button. The board will be programmed automatically during the debug process. So I will press the terminate button. Okay. The board is programmed. The flash was changed by our firmware, and at first I will reset the nuclear board, and then I will connect it to PC through our USB adapter. Let's go to the device manager, and you can see that new device is appeared, and it is called as STM32 audio class. Okay, the device showed up as an audio device, namely speakers. But the problem is that we need a MIDI device class, not regular audio. To do this, I need to change the firmware. I need to change the USB device descriptor, which is implemented in the current firmware. What are USB device descriptors? I will not do any explanation in this video series. So these videos will be targeted at users who already have some experience with the USB protocol. My goal is to give the right direction for those who want to learn how to develop this type of device. In order to implement the desired descriptor, you need to refer to the specification MIDI protocol via USB implementation. I downloaded the last version of USB MIDI specification that is called Universal Serial Bus Device Class Definition for MIDI Devices. That was released in May in 2020. This is a very detailed document where you can find a lot of useful information like functional characteristic, device topology, operation model, and some other information. In this document you can find a list of needed descriptors that we should implement inside our firmware. The examples for each descriptor are placed in the end of document, and you can discover them. For example, MIDI stream interface descriptor, bulk out and point descriptors, and some others. And using the examples of descriptors from this document, I have already prepared my own list with needed descriptors that I placed in separated text document. So you can see this. There are all descriptors that I should to put to firmware. And also I added some definitions in this file. Briefly, the MIDI device interface concept is based on pairs. Each pair has one input and one output that you can see on diagram. According to this, each MIDI device can consist of several pairs or cables. Inside descriptor list, the cables or pairs are defined as jack pairs. If you want to declare more than one pair or cable, you should to increase this value, for example, 2. You should to increase this value, you should to change MIDI cables count definition, and according to this value, you should to add additional jack pair descriptor inside the list. And you can see that amount of jack pairs should be equivalent MIDI cables count definition. And also you should add comment these lines that describes the additional jack pair. In current case, we will use only one cable pair. Let's start to change our firmware. At first, we go to USB device, app, USB disk C. And in this file, let's try to change our USB PID number. For example, to 0. And also, I will change the name of product. That is all for this file. Then let's open the middleware ST USB library class audio source USB audio C file. In this file, we should replace default descriptor list by our descriptor list that we prepared for MIDI device. At first, I will copy our definitions. Place it here. And after that, I should to add some additional variables. The first is the buffer for received data. And the next variable is the flag to notify that data was received. Let's go to the place where default descriptors are implemented. So you can see this USB audio config descriptor. Now I will delete all the code from it. And as the next step, I will copy my own descriptor list. And put it here. After that, let's go below to USB audio init function. In this function, I will only open needed endpoints and prepare one of them to receive data. Due to this, I will delete all the code. Now I will copy needed functions and insert them in my code. Honestly, I took these functions from my old project. Let's copy them. These functions are used for opening each endpoint. One for out endpoint and one for in endpoint. We should to prepare one of these endpoints to receive data. Let's insert this. The data will be received to out endpoint. The direction and the number of the specific endpoint you can see a descriptor list. So let's do this. Let's look to our descriptor list. Let's go to bulk out endpoint descriptor, and you can see that our endpoint number is set to 1 when the in endpoint number is set to 81. This endpoint is used for receiving data. Keep in mind that the direction of endpoint is relative to the host, not to USB device. This means that out endpoint will be used for receiving data when the in endpoint will be used for transmitting data. Keep in mind this. The last step that we should do is to modify data out event function. Let's copy the last function in this procedure and let's go to out event function. It's here. It's called as USB audio data out. As you can suppose, we also will delete this code. No needed this. And paste the function where we will prepare the endpoint to receive the next packet. Also, let's set our flag to 1. That is all for this step. Let's try to build our project. Build finished, no errors, no warnings. That's okay. And then let's try to flash our project. Let's press terminate. That's okay. The program was uploaded. Now let's reset our board and try to replug the USB cable. Now let's go to Bluetooth and devices menu and see what happens. So you can see that our device is detected successfully. The only one thing that confuses me is that MIDI device was detected in other devices block, not in audio. This is very strange behavior because, for example, STM32 discovery works well with implemented USB MIDI device. I mean that STM32 discovery board with implemented USB MIDI converter is detected in audio block as expected, but something goes wrong with nucleo board. I don't know why, maybe you can give me some hint. That is all at this step, and the next video I will implement the function for controlling LED through the MIDI protocol, and I will test the whole solution with external software on the Windows platform. Thanks for watching, goodbye.